Hello everyone, welcome back. I'm the Tech Rancher, and this is results to the homework given to us by Paul McWhorter on the course of Raspberry Pi W, lesson number 6. The homework assignment is to use 3 LEDs, the green, yellow, and red. As I'm just kind of give an example here, we got the green, yellow, and red, along with using a potentiometer. And Paul said the objects of the lesson is to use the 3 colored LEDs, to use a potentiometer, which this one's a 10K, and a Raspberry Pico that we have. Design the circuit to use the items below, and a breadboard to make sure that you use resistors that are suitable for the current being sent to the LED. Connect the wires to the pins and practice good wiring measurement. Well, you can see that I had used a second breadboard to make it look cleaner. Just didn't have enough lines or enough space down below to run lines, so there's a use of a second breadboard right there. This is the layout. We can see here that I've thrown ground to the ground rail, pulling it back up onto the left side of the man, I can't even think of that word. Potentiometer. Then we're using the yellow wire here to represent the data being sent back to the Pico, and then we're using a red wire for the 3.3 volts going to that. On the other side of the Pico, you can see that we're using the blue wire coming up, jumping to the very top of the second breadboard, running down to the red LED, providing data sent to that, which would be the 3.3 line running through there to turn on the LED when we command it to. Then we got the purple running in the center, going to the yellow, and the very last pink running to the green. The pin lays out, so we'll show it right here in the VS Code. Let's go ahead and jump here to the VS Code. Well, wait, let's go here to let's go here to the breadboard and show some math here that we had to do for this. Let me slide over here and try to straighten this up as good as I can. Move the board a little bit out of the way, and see what we can do here for the focus a little bit. Well, not the best because the angle of my camera. Actually, I'm using my photograph camera instead of my phone this time. Hopefully we get better results, which looks like we are getting better results already. We're going to be using a linear equation. Paul did a really good job explaining how to do this math involved. You can see here that I went ahead and did my linear equation, and for the test results that I did with the potentiometer at first was 224 with a 0 axis. On the x-axis, this would be designated as our x-axis, and this would be our y-axis. Okay, so we have nothing climbing up on the y-axis, but we're going over 224. And this is our first one. The 224 represents our 0 voltage being sent. And that's also the 0 for our decision numbering that we got here on the side. Our next for full to the right, turning on, that's what Paul wanted us to also do, was everything onto the right. Potentiometer would be, my readings is 65,535, and we climbed up on a decision number 100. Paul also said let's do 0 to 100 on it. This way we can put it into our if statement to be able to run our code commands. So then I've got label down here for pot valve and decision numbering. We're going to be using the slope of a line. Good formula of a slope of a line for the equation would be m equals rise over run, or m would equal y2 minus y1 over x2 minus x1, or the delta, or the change, or delta y and delta x, or the change in y over the change in x. That's another way to put it. Here we're going ahead and put in the information into it. M equals 100 minus 0 over 65,535 minus 224, which would give us 100 over 65,000 311. Our next formula that we're going to plug in to be able to get to the total equation that we need is the point slope. Point slope is formula is defined as y minus y1 equals m, which m was our slope of a line, times x minus x1. When we went ahead and we put it down here, y minus 0 equals 100 over 65,311 times x minus 224. That would be the point of slope. You could actually plug that in. It's a rough form of it, but you can actually plug it in. But we're going to go ahead and we're going to lower it down to a slope intercept form. This would make it a lot easier for us for our coding to put it in. And it's easier to read too. Which that formula is y equals m times x plus b. To simplify that, we went ahead and I'll show you a little bit what we've done here. Y equals 100 over 65,311 times x, which we'll put that value in here in a little bit, minus 100 times 224 over 65,311. Bring it down to simplify it to where we can understand it. Y equals 100 divided by 65,311 times x minus 100 times 224 divided by 65,311. I like to put it into decimal numbers. For some reason, my mind feels more comfortable with it instead of being into a fraction form. So I went ahead and put it down here and added in our variables. For y actually is decision number equals 0.0015. I just won't go over it all. It's a lot of numbers. Times pot val, which pot val is up here. Pot val is also what we're reading from the potentiometer. Then minus, and this is the right here would be the minus into digital form. Now since we understand that, now we'll go over here and look at the VS Code. I like to use Visual Studio. I've done coding for so long that I just feel more comfortable using VS Studio than the thuming, but that's just me. Okay, I went ahead and put a description in what we're doing, and this is the results for lesson number 6, based off of the course that Paul McWhorter did. Okay, then we get the libraries. What did we define here? To make files smaller, I imported only what I need to use. As you get into bigger codes, you only have so much memory involved in our developing boards, or even actually in any IC or MIC. So the smaller you can make, the better it is. So I went ahead and included the library machine, brought in pin and ADC. That's the only things we really need. And I brought in time, or using the library time, brought in sleep. Once again, minimize what we're bringing in. Setting the variables, pot val, I went ahead and add 0 into it. We're going to be using that right down here below. And then DT is the float valve, 0.5, which is actually 500 milliseconds that we're going to use in this formula. Then we're setting our pins. We use my pot, and then we're declaring it and using an ADC, which is using the library machine ADC sitting at 28, which you're actually using pin 28, or GP 28 actually. Then our LED green, LED yellow, and LED red, and we just specified that those are out pins and said where they're actually located on the Raspberry Pico W. And then now we went ahead and we throw in our loop. We're going to do a try and accept to be able to cancel out when we're done. So we're going ahead and we're trying and bringing in our math exam estimates and bringing pot val, reading the pot val. This is what we did at the very first to get our information that we need in order to do our linear equation. Once we did our linear equation and got to the results, I went ahead and put it into our variable decision number. And right here is what we figured out. And this time I actually put my parentheses in. Good job, huh? Alright, point out values to help determine the calculations. Oh, I'm sorry, print out, not point out. Print, and then I did prints down here. You'll see here when I turn it on, these will be displayed down here in the terminal. Then I ran my if statements. We're saying if decision number is less than or equal to 79, we're turning on the green LED and shutting off the other ones. This is because we're in a loop form. We don't want the other ones on. Next one is if decision number is greater than or equal to 80 and decision number is less than and equal to 95. We're stating if it's in between these numbers of 80 and 95, turn on the yellow LED and shut off the green and make sure the red's still shut off. Then we go to our next if statement. If decision number is greater than or equal to 95 and decision number is less than or equal to 100, once again we're in between the numbers of 95 and 100. We want the green off, the yellow off, but turn on the red. Then we have it set up as a sleep delay. There's a delay in between it as it's running through the cycle. Therefore, I kind of use that for the print. I could actually have moved that up here to the print and could have eliminated it out of our, well, actually no, it would not be eliminated because we're still using the while. True. It's still within inside the loop. There's my, cut that one. Then accept keyboard interruption. So that means that when I come down here and after I hit run, I hit stop, that's a keyboard interrupt, and that will shut off all the lights. That would just, to me, it just looks cleaner. So now we got everything plugged in, turned on. Let's go, and I'm going to start this. And I'm going to switch to our view to be able to show you. Well, I say that, now I gotta find my view. Okay, well you can see I'm already turned all the way over to the point. Alright. And so, if I turn all the way over to the yellow, turn all over to the left, and if I bring up here, and I want to show this view too real quick. I should have done a two camera view here. Wonder if I can bring that in real quick. Just bear with me while I try to bring this view in so we can actually have two views. Want to use an existing view, bring it in here. Let's minimize this down a little bit so you can see what's going on. Alright. As you can see from this view here, we are reading 0 on our decision valve, and we're already far to the left. Turned it to here to the left, and you can see our green LED is on. And watch the numbers as we turn it here. They're increasing. We're at 10, 21, 34, 40, 50, we're halfway. 60, 70, 73. Wow, it changed to the yellow. And what was our decision up here? 80. If I just turn it right down here, just trying to make it up, and right there. See, it's flickering back and, well, kind of making a decision back and forth there, trying to determine. Okay, well, that was enough playing there, but let's go ahead and keep on turning it. We're turning it to the right. Now you see that we made it to the full right, 100, and the red's on. Let's see. So, there we go. We completed a homework assignment. And if anyone has any questions, please feel free to leave a comment down below. I'll be more than glad to try to help answer your question. Thank you, and have a good day.